So when I square both sides, I may come up with something like this that does not work in the original problem. This one is okay because I'm changing the degree, right? As you notice perfectly. So now it's quadratic. It was linear initially. It's quadratic now, so of course the quadratic will have two solutions. But one of them is a byproduct of this not 100% legitimate operation. That's why we always have to go back and check. That's why here I recommend you can say, I don't want to present your restrictions. Fine, I'm fine if you don't want to. But then once you get the solution, you have to go back and plug it in. So it's easier if I state the restrictions from the beginning, and when I get this, I say, oops. And I don't have to go back, and what if I forget to go back? But in this situation, you have no choice. You have to go back and check. Otherwise, you may consider something correct that is incorrect. So if you don't go back and check, you will say, oh, I found the solution. It's 10, but it's not. Because 10 minus 1 is 9. The square root of 9 is not negative 3. So this is not the original problem. You have to check here. Very good question. Anything else?
Can I go over a radical equation, like
yes.
number 5?
Yes. Number 5, number 5. My pages are not in the correct order. I'm sorry. I just realized that. Sorry, my apologies. So we have the square root of 2x plus 7 equals x minus 4. We have no choice, like I just showed this radical equation. We have no choice but to square both sides as one unit. So you cannot say this is this squared and this squared. No, 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 no. This, where are my props, equals this. When I square this as one unit, and I square this as one unit. So now, the left-hand side is easy. How many terms we have on the right?
3.
Thank you very much. It's this or this. That's why we have 3. Excellent. So, can anyone give us the right-hand side?
X squared minus 8 plus 6.
Very good. Very good. Now this is quadratic. I know I will get two solutions, and I will have to check. These are my notes, my side notes. Don't forget, this is quadratic. Now you square both sides. It was a radical equation. Now it changed into a quadratic. You will get two solutions, but you must check them in the original problem. I move everything to one side. I keep the x squared. I subtract 2x. I subtract 7. If factoring takes 10 seconds, 30 seconds, 20 seconds, fine. If not, quadratic formula. But it's okay. It's x minus 1 and x minus 9. And we get 1 and 9. I cannot emphasize enough. If you leave it alone, you may be wrong. We can't leave it alone. But we cannot plug it in where it's not, this is not the original problem. I have to plug it in here. I'm going to plug in 1. I know it's not going to work. 1 minus 4 is negative 3. This number is never going to be negative. What about 9? 9 times 2, 18, plus 7, 25, 9 minus 4, 5, 5, 5. Yes. Good. Next question.
Can we do number 6?
Yes, number 6. Solve the equation by making an appropriate substitution. Very good. So this is x to the 4th minus 29x squared plus 100 equals 0. Make myself a note. Polynomial. Also substitution. or quadratic in form, 4 solutions. This is my note to myself. Don't forget, it's polynomial, but you will use substitution, or it's quadratic in form. And 4 solutions, I have to get 4 solutions. Okay, so obviously the substitution, I always look at the lowest degree. So if I denote this, let's say by t, if this is not t squared, I cannot continue. But it is t squared. Because when I square x squared, I get x to the 4th. So the equation can be replaced by t squared minus 29t plus 100 equals 0. If factoring takes more than 15 seconds, let's say, forget it, quadratic formula. But it's okay, it's negative 25 and negative 4. So t minus 25 and t minus 4, nice, t equals 25 and t equals 4. But these are 2 other equations, because now I have to go back and replace t by x squared. So this equation is x squared equals 25. This equation is x squared equals 4. I know they are quadratic. I know I will take the square root. I know I have to write plus or minus. And this is how I get my 4 solutions. So x will be plus or minus 5 from this equation. And from this equation, x will be plus or minus 2. And I got 4 solutions.
Will we go over number 8?
Yes. Any questions on this before we look at 8? Anyone? And don't forget, if there are any situations with Zoom, like one of your colleagues experienced some difficulties, call me, because my phone is on. I keep my phone on just for these situations when somebody cannot get in or something, because I may not see an email, I may not see a chat with all this equipment in front of me. I talk too much, I know. You said number 8, sorry, number 8. Yes, so the absolute value of 7x minus 7 divided by 7 is greater than or equal to 9. Perfect. So let me refresh your memory a little bit on the absolute value inequalities. And they are of 2 types. So one type is here with 0 in the middle, this piece. And the other type is this, as well as this. This one, because it's greater than or equal to, it will be this situation. And we will have to use the union, because it's the absolute value greater than or equal to a number. Don't forget, this situation with greater than is outside, and the solution has to have the union. Now I look inside, and remember, simplify, factor. I see that I can pull out a 7 in there, inside x minus 1 divided by 7, greater than or equal to 9. I want to simplify things, and I will. This is much more human now. And since I'm looking for the outside, I have to write that x minus 1 is to the right of 9, here, to the right of 9, or x minus 1 is here, to the left of negative 9. So this one means x greater than or equal to 10, and this one really means x less than or equal to negative 8, because we're adding 1 to both sides. So that's my solution with the union in between. I start with the smaller one, from negative infinity to negative 8, and then I put the union, the one from 10 to infinity. This is always going to be the case when you have an absolute value greater than or just or greater than or equal to the union. I think I heard number 7. Yes?
Yeah.
Perfect. Any questions on this one? Before we look at number 7. Any questions for me? I want to say, not because I like to, you know, I am in your corner, that's definitely for sure and forever, but this is a very good class. I've noticed that many of you are just doing very, very well, and I'm very happy. Okay. One other thing that I want to mention before we start this is do not be afraid of fractions. What am I trying to say there? Do not be afraid of fractions, please. In equations and inequalities, you can eliminate them so fast with the speed of light. How do I eliminate fractions in this situation?
Multiply by the lowest common denominator.
Excellent. Which is?
12.
That's it. I multiply this by 12 over 1. I multiply this by 12 over 1, and I multiply this by 12 over 1. We simplify always before multiplying. Please simplify before multiplying. So I simplify 12 and 4 by what?
Dividing 12 by 4, you get 3.
Exactly. So now I write 3 times whatever it's in there. Greater than or equal to. I simplify. I don't care what's up there. 6 and 12. 6 divided by 6, 12 divided by 6. And now this becomes 2x minus 7. And of course, plus 1. Now this is way more human than what I started with. So please do not be afraid of fractions. You can always, especially in inequalities or equations, you can always get rid of them in a blink. You have to find the least common denominator, but you can always. We always simplify before multiply. Okay. So now the rest is easy. 3x minus 42 greater than or equal to 2x minus 14 plus 1. First I combine like terms, and then I will be moving 2x to the left and 42 to the right. So 3x minus 42, and this is 2x minus 13. I'm moving 2x, I'm moving 42. So this is x greater than or equal to positive 42 minus 13. 42 minus 13. I think I get 29. And that's the interval notation right there. 29 to infinity. Greater than, to the right hand side of 29.
Would it be wrong to subtract 3x and then add 13 to the other side? Instead of subtracting 2x and then adding 42.
No, you'll get the same answer, but then you'll have to divide by a negative number, and you have to switch the symbol. Just be careful. You'll get, of course, it's not incorrect at all. It's fine. But just make sure that when you do that, I have a habit of 99% of the cases keeping the variable on the left. That's my habit, but you don't have to acquire that habit. I'm not saying it's good, I'm not saying it's bad, it's just a habit.
Question. What does it mean when x is equal to 0?
Say it again.
What does it mean when x gets cancelled out?
In an inequality?
Yes.
Very good. Very good question. Excellent. So let's say x minus 2 less than or equal to x plus 9. Something like that, correct?
Yes.
Good. So I subtract x from both sides, and I get the statement that negative 2 is less than or equal to 9. Is this, you're going to tell me, is this a true statement or is it a false statement?
It's true.
Good. Because it's true, then we'll say x in the interval negative infinity, infinity. Who cares what x is? This is always a true statement. For any x, this will work. If I put 10, is 10 minus 2 less than or equal to 10 plus 9? Of course it is. If I put negative 5, is negative 5 minus 2 less than negative 5 plus 9? Of course it is. If I put 10,000, is 10,000 minus 2 less than or equal to 10,000 plus 9? Of course it is. So I get all real numbers. But here's another situation. X minus 2 greater than or equal to x plus 9. I subtract x from both sides, and I get negative 2 greater than or equal to 9. Now you're going to have to tell me whether this is true or false. This is false. Therefore, no solutions. There is no x on this planet that will make negative 2 to be greater than or equal to 9. Very good question. Thank you. Next question, please. Next question, please.
I don't have any more questions. I don't know about everyone else.
Can you go over the type of question that was on the last quiz?
Yes, I don't remember what it was, but I can open it. If you have it handy, give it to me. If not, I can go back to the quiz. You need me to go back to the quiz? Okay. So let me go back to the quiz. I just don't remember. Was it the difference quotient? Okay, assignments. That's how I go to assignments, and let me see. The last quiz. 2.2 preview. I'm clicking on it right this moment.
It would like the f of x plus h.
Okay, yes. So the function was negative 3x squared plus 14x plus 23. And we are asked to find and simplify the difference quotient, which the formula is given to you. We wrote it so many times by now, I'm sure you remembered it. So this piece is negative 3x squared plus 14x plus 23. But there is a minus in front, so that minus will eventually be distributed to all terms. This is very clear. What I don't have is this piece. So I'm going to work on that first. So f of x plus h. Can anyone help us how to write f of x plus h? So remember, the function is telling us this.
You replace h plus x plus h on the x.
Yes, I replace x. Everywhere I see x by x plus h. Good. First I have to square this. How many terms do I get when I square this binomial?
2. You get 3.
Thank you. So, and those three terms are?
X squared plus 2x h plus h squared.
Great job. Plus 14x plus 14h and plus 23. I have to distribute negative 3 to these three terms. All this will replace this. So, the difference quotient. Watch me run out of room. I always do. Look, I need a table as well. Okay, so negative 3x squared minus 6xh minus 3h squared plus 14x plus 14h plus 23. Now here, the opposite of this, positive 3x squared. The opposite of this, negative 14x. The opposite of 23, minus 23. Of course, as I promised, I ran out of room. Remember, two things have to happen. All terms from the top that do not have h must simplify, must cancel. If they don't, I have a terrible mistake somewhere. Okay, the negative 3x squared with a positive 3x squared, the positive 14x with a negative 14x, and the positive 23 is a negative 23. I'm happy. All terms without h are gone. Now I'm left with three terms. All these three terms have to have h in common, because the second thing that has to happen, this h in the denominator must go away. And that will be the final answer. But what do I have here inside? And I have to have three terms because I started with three terms. Can anyone give us those three terms?
Negative 6x minus 3h plus 14.
That's it. So that's our answer. Negative 6x minus 3h plus 14. And that is